Hello everyone, our lesson for today is all about compound inequalities. When we say compound inequalities is formed by joining two inequalities which the connective word and or is useful. Like for example here, when we put and or, there is an in specific form that we can use the and or, that which and is the intersections and or is the unions. When we see the example here, x positive 1 greater than 3 and x negative 11 is less than 7, which we can see in and here we can use the intersections with the number 2, which is x positive 3 is greater than 5 or x negative 1 is less than 9. When we see the solution set of a compound inequality, which the connective word or is the union of the solution sets of two inequalities, and the solution set of compound inequalities which connective word and is the intersection of the solution sets of two inequalities. Let's have an example number 1. We have 2x less than 10 or x positive 1 greater than 9. And then first we need to solve in the first inequality. We have 2x less than 10. And then when we simplify this one, first we need to divide each side by 2. And then cancel out 2. The remaining is x. Then 10 divided 2 is equal to 5. So x is less than 10. Then the set builder notation here is the set of x less than 5. Let's go to the second inequalities, which is x positive 1 greater than 9. Then when we simplify this one, we need to add the negative 1 to each side. So cancel out positive 1 and negative 1. And the remaining is x greater than 8 because 9 minus 1 is equal to 8. Then the set builder notation here is the set of x with or it is the union. You put the union here. So the set of x greater than 8. Which is equal to the set of x such that x is less than 5 or x greater than 8. And this is the answer. And then let's have an example number 2. We have x positive 3 greater than 4. And when we say and is the intersections of 2x positive 1 greater than 15. So first we need to simplify the first inequalities, which is x positive 3 greater than 4. We need to subtract each side by negative 3 and then cancel out positive 3 and negative 3, and then x is greater than 1. Then the set notation here is the set of x such that x is greater than 1. The second inequalities, which is 2x positive 1 greater than 15, then we need to add both sides by negative 1 and cancel out positive 1 and negative 1. The remaining in x, 2x. So we need to divide each side by 2 and the remaining is x greater than 7 because 14 divided 2 is 7. And the set notation here, the set builder notation here is the set of x such that x is greater than 7. So when we join together here, we can put the set of x such that x is greater than 1. Intersections with the set of x such that x is greater than 7, which is equal to the set of x. You can put here the set of x such that x is greater than 7. And this is the answer. And then let's have an example number 3, which is 2x positive 5 greater than negative 16 and 2x positive 5 less than 9. The first inequality, so we have to subtract each side by negative 5, then cancel out this one. The remaining is 2x greater than negative 16 plus negative 5 is negative 21, and then we divide each side by 2 to isolate the value of x. So we have x is less than negative 21 over 2. When we say negative, so it is the reversal of the directions of the symbol. So the directions of inequality, it becomes less than just because of this negative. Set builder notation here is the set of x such that x is less than negative 21 over 2. Solve in the second inequality here. This one is the, when we say end, is the intersection, so we need to subtract each side by negative 5, cancel out 5 and negative 5, so the remaining is 2x. Then we divide each side by 2, cancel out this one, x is less than 2. And then we can put the set builder notation here. The set of x less than negative 21 over 2 intersections with the set of x such that x is less than 2. And the set of x here we can put here is the set of x such that negative 21 over 2, since it is less than, so we can put first the number and less than x less than 2, and this is the answer. So the example number 4, we have negative 4x positive 5 greater than 9, or 4x positive 1 less than 5. And then we can solve its inequality. First, we can solve here by adding negative 5. So we have cancel out, and the remaining is negative 4x greater than 9 minus 5 is equal to 4. And then this one, we divide each side by negative 4 to isolate the value of x. So cancel out negative 4, and then x is negative 1. Since it is negative, we can reverse the directions of the inequality, so it is x less than negative 1. So the set of x such that x is less than negative 1. And then the second inequalities here, so we need to add both sides by negative 1, so cancel out positive 1 and negative 1. The remaining is 4x less than 5 minus 1 is equal to 4. So we divide each side by 4 to isolate the value of x. So we have to divide this, cancel out 4, and the remaining is x. Therefore x 4 divided 4 divided by 4 is 1, so x is less than 1. And this is the union. So the set value notation here is the set of x such that x less than negative 1, union of the set of x such that x is less than 1. And then which is equal to the set of x such that x is less than 1. We can put only 1 here. And this is the answer.